Welcome back. This is the final part of this motors and doll starting thing where I'm covering a lot of doll starter stuff. And now we're going to throw in something that's not been there before. We've been talking loads about start and stop buttons, yeah? But what about if your start and stop buttons look something like that? Because we need to get used to the concept that start and stop doesn't need to be buttons. It doesn't need to be a human. It could be a relay or a contact or a sensor, or it will always be some sort of switch, but that switch doesn't have to be operated by a human. It could be operated by a product, a magnet, a sensor, and all sorts of stuff. So let's dive in there and look at what alternatives we've got for starting and stopping, but not with start and stop buttons. Hold on, it's going to be a rough ride. And also, in case you don't notice, this is a makeup shot. I'm filming this about a month after. I've just literally put the same shirt on and hope my beard's the same length. And I think that light bulb's in the wrong place, but there you go. Enjoy the video. One more thing I want to throw on this video is the concept of normally open, normally close. I'm going to throw in the stop button and the start button things. You can have as many start buttons as you want in... Go on then, tell me. In parallel. You can have as many stop buttons as you want in series. We did that in video 2. But I use the term buttons. But let's just say you can have as many stop items and start items as you want. For example, in this pump situation here, if there's a tank here and it's topping the tank up that's a mile away, have I got to sit here and do that? Fuck's sake, mate. What is going off with the juice? God damn it. Fucking not on again. You absolute fucking c***. Right, there you go. Got power now. I should have known to listen to water power in. Have I got to sit here and start it and stop it all day long? Because that would be a very, very boring job for me. So let's prove that you can put other things in that be start and stops. So start and stops don't need to be buttons. Because otherwise, we'd have humans doing stuff. They can be just relays that are controlled by, say, a computer, or they could be snazzy buttons. Let me show you. First of all, let me get rid of this fucker because it's right in the way, and let's get something that's a little bit more useful to show that a start and stop button can be other items, especially in this pump situation that we're dealing with now. Oh, fucking hell, where's a fucking ton, mate? Oh. Right, so what I'm going to do is, we're going to make these pump switches control this pump. Now, these switches would be at this end. So the tank we're trying to fill at this end would say, I've not got enough water, start the pump. Then when there was enough water, it'd stop the pump. So we'd have a manual option, which is the push buttons. We'd have an automatic option, which would be these floats. One of the things I want to get across here was a thing like on this overload that normally open, which has brought that little trip light on over there, and the normally closed can sometimes appear to be the wrong way round, because normally open and normally closed are in the normal or abnormal states. And one thing with this that you need to be aware of is that if you want to play with the rig like this or do floats like this, you have to be aware that there's a process value in. I thought I'd not recorded this then. There's a process value in there, or a process, or what the fuck am I on about? I'm trying to say, basically, let's get this right this time. With these floats, there would be water. So obviously, you'd want to turn it on when it got low. This is the low float. And you want to turn it off when it got high. So some people do this. On. Off. That is wrong. If you think about how water operates, you'll know why that's wrong. It doesn't go on, off. It does this. The water will rise. This float will go on and it will stay in that position. And as it rises more, it will take that up and say off. And as the water drops down, it will come down like that and do nothing. And it will come down like that and do something. So let's think about the pump running with the water and just go through that process. So in this case, we're trying to fill a tank at this end from when it's empty to a set value. The empty is down here and the set value is up here. So if we imagine the pump is not running and we manually start the pump because the tank is empty, what would happen is water would come in and lift this float up. And at that point, nothing would happen because we'd manually start to fill it. That's not the full one, that's the low one. Then as the water rose and rose and rose and rose, this one would go in and the pump would stop. However, the float would stay in that position because eventually the water would naturally come out of the tank and it'd come down, nothing would happen, and then the water would come down the tank, down the tank, down the tank, and then it would start again. Then water would get pumped in and nothing would happen, and it'd fill up and it'd stop, go down, it'd start, go down, it'd stop, whatever, you get the idea. You've got to think like the water, yeah? So call me stupid, you can. If I'm not mistaken, this one will tell you it's low and it will start the pump, but it won't start the pump there, it will start the pump as it drops. And this one will stop the pump, but it won't stop the pump there, it will stop the pump when it does that. So now we need to work out in what positions they are needed to operate to do what thing, and then get the normally open, normally closed correct, because these are capable of doing normally open, normally closed. So which one start and which one stop? That's a start and that's a stop. So let's make a note of that. Right, so what I've done is I've gone away and checked my working out. Maybe what I said before was shit, but what I'm saying is when this float goes upwards, it's the stop signal. And when this float goes downwards, it's the stop signal. Well, stop needs to be normally closed and start needs to be normally open. So now what I need to do is go down here to these terminals that are the wires coming from these and find those contacts for each one with my multimeter, which I'm not going to show because it'll be fucking boring. But then I'm going to show you me wiring it in to do, I just burped, to do the automatic bit. Let's do that. I'll get that all prepped up. So I'm not going to show you, it'll be boring. They're just switches. It's a little bit complicated because they floats. Yeah, if you want to do it for real, these floats cost me £3.50 off eBay for the pair. It's fucking ridiculous, mate. So if you are thinking about knocking some of this up, it's not prohibitively expensive to buy a shitty second-hand 24-volt contactor and all your gubbins, yeah? Anyhow, just one other thing. So I'm using this shop and test today, and I used to bum fluke test leads, yeah, so how fucking great they were. I'm not being paid for this. This is just a genuine thing I've just noticed. Honest. They paid for this office. Get over it. I used to bum fluke test leads. And I never thought, I don't think the Chevron ones are as floppy, but you see how thin they are. Yeah, not many test leads are made that thin that they'll just go into terminals. And they will, which is good. Because normally to fuck around shaving up, but they will actually fit in there, which is nice. So stick that in continuity. You could probably hear that beeping. I'm going to test this one now. This one wants to be a normally open. So if I go in the common. Oops. That's close. I'm going to do this off camera because it's just me testing things. It's fucking boring. I'm not trying to show you how to test a probe. I'm trying to show you how to wire a alternative start and stop system up and watch it work. So I'll be back in a minute. Right then, I've wired this start one up. I've got the right cables so that as it falls, it makes the contact. That is just the same as you pressing the button. Although that ball didn't fall then. So now this acts like a start button being pressed when it gets to its lowest level, like that. Let me show you the stop. As you'll hear, this is currently normally closed, and as it rises to the top, it opens like a button, stop, stop. And if we remember, the water's going to come up and activate these in a certain way, but I'm doing another take, so it's beeping and get on my tits. Good beep though. So they're wired in now. I've used the pink ones at the minute are from a start, and the blue ones are from a stop. So all I've got to do with these alternative push buttons is wire them in series and parallel into the start and stop circuit, which I'm going to do. I'm not going to show you how to do that because I've said on every fucking video I've done, you just put the stops in series and the starts in parallel. Like, if you can't work it out, draw it, because drawing, following it with your finger, is how you'll learn. But let me just wire it and show you the alternative, because the next video I'm going to do, we're going to get rid of these because these are a pain in the but I'll come to that in a minute. Right then people, hopefully you're following along at home. Hopefully you can just see, if I move you that way a little bit, you can see the box. Now, if I press the stop, I can stop it because I've wired the stop button in. If I take the stop out, it just starts up straight away. That's because these floats do something that buttons don't do. They're automated. It's automatic now. That's how it functions. So now, if I cut the power, it stops. But if you put it on, it will start up automatically. This is the feature of automatic things, because these switches don't need to be pressed by a human. At the minute, this tank thinks there's not enough water in it. Now, if we pretend to be water and come up like this, up, nothing has happened. But if we pretend to keep coming up, getting full, and it's stopped. And it would stop there. Then as the water got taken out, this one would go down, and nothing happens. And then this one would go down, and it'd start again. And it'd fill up, up, nothing happens, up, and it stops, and it empties, and it stops. And there you go. That is an alternative to push buttons. Again, just using normally open, normally closed contacts to pretend to be those push buttons. There's a little problem with this. It's a great demonstration, but there is a problem, and I'll show you what the problem is. At the minute, the tank's doing its thing. That's fine. But if I come over here and press start won't work because the tank's doing its own switching. Start won't work because it won't, because of the way I've wired it. So the buttons don't work anymore. I can stop it when it's running, and I can start it when it's stopped. But that's because what I've done here now is I've intermingled my manual and my automatic devices, which you don't generally do because it's a bad idea. So what you would incorporate in this is, on this toggle button over here, you'd have one side for manual, one side for, the middle would be stop, one side for manual, one side for automatic. It is difficult to incorporate successfully manually dependent push buttons operated by a human with automatic buttons stopped by a process. So there. I'm not going to tell you how it's done, but what I'm going to put up at the end is I'm going to put a drawing up that shows a system that is started. It's not this one, it's not the pump example, it's another example for you to do fastest following your finger firsties. I'm going to put up a drawing that incorporates everything here. It incorporates automatic, although it's by a PLC contact output, and it incorporates start and stop buttons, and it incorporates a toggle switch to select between manual, off and automatic, which is how you'll find the vast majority of things like this are done. So that concludes the three parts this little thing. It's three parts. This is the last one. But the only way you'll ever be ready for all eventualities, like the off, on, manual, the start, stops, the automatic floats, is to be able to read drawings. So I'm going to make a set of drawings available somehow. If you get your hands on any drawings at work, or you can just get some drawings, don't take the proper drawings. Always print out a copy of some drawings you want to work with and work with those separately. Yes, if you want some drawings to work with, somehow I'm going to get a copy of the drawings online, hopefully, somewhere located. Or you can just Google drawings anyway. Or you might have some work, like I say, don't take the drawings out of your control panels. Always get a PDF, print them out, cut the corner off so that you know you're dealing with a set of drawings that's not related to a job that's being used for practicing stuff with, yeah? I can't go any more than what's in these three videos. Everything's covered in these three videos. It's just a case now of how you arrange your stop and start circuits, how you arrange normally opens, normally closed to get the thing you want to do. You can have huge change of normally opens, normally closed, and things can get complicated, but generally they will always boil back down to the fact that you've got a dull starter in the process. And if you know that, you can usually work it out. And if you know you've got your different layers of indication, control, and blah, 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 you can work it out. But it's a long one, this is. It's really got to end because this shit can go on forever. You can have pump systems with 30 sets of these that just work. So, yeah, good luck out there on your own. Not really. Take away from this that stop buttons are always in series and normally closed. Stop buttons are always in parallel and normally open, unless you've got some weird control system. Don't quote me on that. All your auxiliaries exist. Auxiliary blocks, auxiliary contacts, relays and that, knowing they have coils, knowing how they work. I'm going to do a video on drawings shortly. It's probably going to be the next video I do. It's going to be like a computer one where I just show you around drawings and show you how to use drawings. The only way you get good at using drawings and looking at control systems from the drawing aspect and following through is to know the basics. Normally open, normally closed contacts, auxiliaries, start and stop buttons. I can't do any more than that except do a video on drawings, which I will do on this channel before the end of the year, just to wrap it up as this series, because after next year I'm not going to fucking bother doing videos every week, but that'll be there. So yeah, you've got to get them out. There's no quick solution. There's no hints or tricks or hacks. You've got to look at stuff and understand how it works, and look at drawings and understand how they're drawn. And in fairness, like, I don't go to every job I do and just fucking work it out straight away. Sometimes I draw it out, sometimes I get it wrong, like I've done a few times in this video. Sometimes I have to get the drawings out and look at them. Sometimes I work out as bonds been made. It's not a shortcut, There ain't no one out there just fucking does it off the back. Norm, it's the drawings and that. And so, yeah, don't feel downtrodden when you're starting. But once you apply the basic principles and stuff, you can pretty much work on your motor circuit. Anyway, fuck off now. I'm going to smoke a pipe. See you later.